So I want to take just a few minutes and talk to you guys about the fundamental theorem of calculus, and this is section 5-8 in your textbook. I want to use it today and talk about a few examples today, and then in class, next time I see you guys, we'll talk about kind of where it comes from and how it relates to the mean value theorem. So the fundamental theorem of calculus is really important because it allows us to solve integrals without using a Riemann sum. So far in this class, in order to look at an integral, say you have the integral of x squared dx from 1 to 4. For example, first you'd have to draw x squared, then you'd have to get it from 1 to 4, and then you'd have to partition it, right? However, whatever number of n I give you, then you have to figure out the area of each rectangle, and then you have to add them all together. Okay, now, this is a long, tedious process, as you've seen. The fundamental theorem of calculus allows us to shrink this process down. So what the fundamental theorem of calculus says is that g of x is equal to the integral of some function, f of x dx. Now, keep in mind that for g of x to equal the integral of f of x with respect to x, f of x itself needs to be integrable, right? You need to be able to take an integral of that. Otherwise, it doesn't make sense. Okay, so f of x is an integrable function, and g of x is the integral of f of x with respect to dx. So we can say if this, then when you have a definite integral, remember we have endpoints now, so a definite integral from a to b of f of x dx is equal to g of b minus g of a. Okay, so we can do an example of this, and it's pretty straightforward. As long as you can take an antiderivative, you're pretty set with using this property. Now, the difficult part comes from understanding where that comes from, but again, we're going to tackle that together in class next time I see you guys. So let's go ahead and just use this now to do an example so you can get the hang of how it works and where it comes from. So let me move this page up, and then we'll do an example, and then that will be it. Okay, so example 1. Calculate the integral from 2 to 7 of x squared dx. So in order for me to apply my fundamental theorem of calculus, I need to be able to take my integral, okay? So first I need to figure out what is the integral of x squared, okay? Ignore the endpoints for a second. We just got to figure out what the integral of x squared is. And hopefully you know that your integral is your antiderivative. So my integral of x squared would be 1/3 x cubed. And we need to take it from 2 to 7. So this vertical line here means that I'm finding a value from x equals 2 to x equals 7, okay? And sometimes, depending on who your college professor is and where they went to school and whatever, they'll also put like a little x equals 2 here and an x equals 7 there to remind them that that's like the boundary of where they're taking their integral. So I took my integral. It needs to be evaluated at 2, it needs to be evaluated at 7, and the fundamental theorem of calculus says that I can plug in the top function, and I can plug in my top value to my function, and I can plug in the bottom value to my function, okay? So when I do that, I'm going to get, so this is going to equal 1/3 times 7 cubed. Again, I just had this 7, so I plugged it in there, okay? And then I have to subtract, because that's what my fundamental theorem says, so I'm going to subtract my function with the value of 2 plugged in, okay, or my lower bound plug in. And I need to cube that as well. So 7 cubed is 343. So I have 343 times 1/3 minus 1/2 times 8, which is 2 cubed. And then that will give me 343 over 3 minus 4. Now, you want your answers to be as exact as possible. So the second that you take this and you divide it in your calculator, your answer is no longer exact. So do not do that here. Okay, that's not what you want to do. It's not going to be to your benefit to do it that way unless you're doing a multiple choice test and the answers are in decimal form. Okay, that is not what you want to do. So take 4, put it over 1, get your common denominator, and you're going to end up with 331 over 3 is your answer. Okay, so that's the value of your integral. Pretty straightforward. That's it. Make sure you get all this down. If you have questions, write them down. I will be checking this work.